Hello everyone, welcome to our EUCS 6893 Big Data Analysis final presentation. And our project is log anomaly detection. And our group members are Wenliang Guo, Zixuan Li, and Chaoyu Fan. So the modern computer systems emphasize more and more on robustness and resilience to abnormalities in different operating conditions. System states and critical point analysis are important to record and review in order to analyze and further avoid system errors. Therefore, we propose a novel method of anomaly detection.
Some people use rule-based methods. The drawback of these methods is that they must be used in a specific environment and cannot be applied universally. Traditionally, in addition to the rule-based methods, logs are usually checked manually through keywords research. However, model systems are increasing in size and complexity. In order to reduce the manual workload, many anomaly detection methods based on automatic log analysis has been proposed. One of them, deep log, is a representative model and that enables online anomaly detection. We designed the TransLog model, which has better performance. Deep log models use LSTM, although LSTM has handled long-term dependencies, but there is a forgetting gate in it. So it's not very good for log detection performance. TransLog mainly use transformer model, which doesn't have forgetting gate, and it can save the whole block without missing information. So the detection performance is better. For the data size we download is HDFS logs, which has 570,000 logs. Due to our computer hardware configurations, we train very slowly. To improve efficiency, we randomly select 2,000 data from it to be our data set for this project.
Then I will talk about the methodology in our project. The previous approach mainly based on the handcraft features or using some traditional machine learning algorithms such as the PCA. But as the development of deep learning, DeepLog is the first one that uses the LSTM neural network for log anomaly detection task. And inspired by the DeepLog, we introduced Transformer to improve the performance, and we proposed the TransLog in this project. Here is the diagram of our proposed TransLog. It composes the log parser and the anomaly detector components. First, in the log parser, we use string algorithm to parse the log. The raw log message are split into the log key and log parameters, two parts. And then we send the log key and log values to the anomaly detector to perform the anomaly detection. The anomaly detector is composed of a series of transformer layers and two fully connected layers for classification task. And each transformer layer includes the layer normalization, the multi-head attention, and the MLP blocks. The advantages of transformer layer is the global self-attention mechanism, which can capture the features of a larger windows than the LSTM used in the DeepLog.
We trained 6 models to compare. The dim column represents the embedding dimensions. The depth column represents the network layer. From the table, we can see that large TransLog has the most embedding dimensions, and its network is most complex. Meaning TransLog embedding dimension is the same as the TransLog, but the network layers are less than TransLog. To prevent overfitting, we set the dropout to 0.5, which is larger than 0.1. These two models on the right are our comparison models, and the LSTM model is the main component of the DeepLog model. As we can see from the figure, compared with other models, the training loss of the large TransLog does not converge complete in the end, and its validation loss obviously does not converge well. This is because the network model of large TransLog is the most complex, and our 2000 data size are too small for it. So the model validation effect is not very good. In addition, the blue line indicates our TransLog model, which has the best validation loss convergency compared with the LSTM and the GRU models of the deep log. Although the performance of TransLog is better in all comparisons, the parameter comparison shows that TransLog has more parameters than the deep log model. So the deep log model is more efficient in platforms with lower arithmetic power.
There are two examples of using log anomaly detection to create business value. The first example is in e-commerce. Anomaly detection can be used to spot pricing glitches and product quality issues to avoid the loss of revenue. The second example is in fintech. By using anomaly detection, we can stay ahead of advanced attack, so the customer and financial partners have confidence that the transactions are safe.